Okay, continuing on. Given a vector for I plus 2j, so there's the vector. If I wanted to know the angle that it makes between the vector and the x-axis, this angle theta, well, this is 4, this is 1. What do you think? Tan of theta equals 1 over 4, and theta will be the arctangent of 1/4, and that would be 14.04. We know this from trigonometry. Refreshing your memory on how this works. Now, a child pulls a wagon with a force of 100 newtons. The handle makes a 45 degree with the horizontal. There's the horizontal. And the child is pulling this wagon, and it makes 45. It's not centered. Let me center that really quick. 45 degrees, and I know this is 100 newtons, and something that you're going to be asked to do a lot, write it as a vector. So if I want to write it as a vector, if I know this is, the magnitude is 100 newtons, and this is 45 degrees, wouldn't you say, and this is vector v, wouldn't you say I could write v as the I component is really the cosine of 45 equals the I component over the magnitude, which is 100, and if you cross multiply 100, the cosine of 45 degrees, and with the same argument, isn't that 100 sine of 45 degrees? So I could write that vector as, and this is radical 2 over 2, so this is 50 radical 2, 50 radical 2. Something that you have to do all throughout. I could write this vector as 50 radical 2, 50 radical 2. But that means you're feeling a force in the I component by 50 radical 2, and the J component 50 radical 2. That's what this is feeling. That's how it feels like. That's how much pressure is applied in the I and the K component. What if I have two vectors? Well, now that I know what I know, if this has a magnitude of 30, call this F1 and call this F2. Well, if I could write this as a vector, can't I say this is 60? Isn't this 30 the cosine of 60 degrees? And this is 30 the sine of 60 degrees? And what's the cosine of 60? Isn't that a half? And the sine is radical 3 over 2. And if you ever forgotten those, you could always draw the triangle really quickly if you've forgotten. 1, 2, radical 3, and it's 60. Cosine is the adjacent over the hypotenuse, and sine is the opposite over the hypotenuse. And here it's 45 degrees, so I could say this is actually 14 times cosine, radical cosine of 45 degrees, and this is 14 the sine of 45 degrees. So this is 7 radical 2, 7 radical 2, with one exception. Instead of going all around and doing all of that trick, I know this is, the j component is negative. The I is positive, but the j is negative. So I could just fix it that way. That's an easy fix instead of going to 315 degrees. And now if I really think of the resultant, if I mimic this vector, and I mimic this vector, isn't the resultant really right there? So if this is f2, and this is f1, or this is f1, however you want to see it, f2, wouldn't you say the resultant is the sum of those vectors? Right? Wouldn't you say the resultant is simply f1 plus f2? That's what it means by these vectors. So the resultant will be 15 plus 7 radical 2 and 15 radical 3 minus 7 radical 2. That will pretty much explain the resulting force out of those two vectors. And if you want to find the magnitude, well, that's easy. If I have a vector, I know how to find the magnitude. That's the square root of the I component squared plus the j component squared. And that would be in newtons. And if I want to find the direction, well, if I have a vector, I know how this works. I take the tan of theta, right? And it's going to give me this angle, right? Because that's the resultant vector. That's going to be the j over the I. And wouldn't that mean that theta equal the inverse tangent of 15 radical 3 minus 7 radical 2 over 15 plus 7 radical 2? And that would be how many degrees? And I'm going to do that really quick. So if I take parentheses 15 plus 7 radical 2 squared plus 15 radical 3 minus 7 radical 2 squared, radical, square root of that, at 29.64 newtons. And if I want to figure out the angle, I'll take parentheses 15 radical 3 minus 7 radical 2 divided by 15 plus 7 radical 2, and I'll take the inverse tangent. Make sure you're in degrees. We are. If I take the inverse tangent of that answer, it turns out to be 32.9 degrees. And there it is. And that's pretty much it for this section.